Alright, so for today we are going to have a video that cover our chapter 7. So chapter 7 is actually about differentiation. Alright, okay, so before we start this chapter, generally you need to know it is actually a long chapter. Okay, for this chapter it is quite long and it is quite important because for a lot of partial questions, you will realize that there are a lot of marks actually coming from this particular chapter. Or maybe usually the questions that involve this chapter usually is quite long, therefore it contributes quite a lot of marks. Alright, so please think on this part. Okay, so it is quite an important chapter. So differentiation is important, and then the other chapter is integration, which is chapter 8, also important. Alright, so these two are long chapters. Okay, so we will start with our first part of differentiation first. Okay, so for today's video, we are going to cover some very simple differentiation. Okay, use the derivative of x power n together with the constant multiple, how to differentiate some differences of functions, and also convergent function by using the chain rule. For today's lesson, we are just going to cover some very basic techniques on differentiation. Alright. Okay, so first we go through the rules of differentiation. So again, I believe that most of you already know all the rules here. You learned it before actually. Alright, so it is just again a quick recall for you all. Alright, okay, so let's start. Okay, so first, when you want to do any differentiation for a constant function means it is a number. So as an example, fx equals to a k. Okay, so when you do the differentiation, it will be f prime x equals to 0. Alright, so just to recall back, the differentiation for function fx is f prime x. You see the symbol here? I hope that you can see the symbol here. It is f prime x. Alright, so or the other way around, if let's say they actually give you a equation in y. So let's say y equals to 4. Alright, so if let's say you want to do the differentiation for y, if you want to use the do the differentiation, get the differentiation for y, it will be dy over dx, which is equals to 0. So the symbol for the other pattern, that means they give you the equation, y equation, then the differentiation will be dy dx. If they give you the function fx, then the differentiation will be f prime x. But generally, these two are having the same meaning. Okay? Alright, so this is how we do a differentiation for constant function. Okay, so the next one is a function of the form x power n. Alright, so when you're having fx x power n, so again, how are you going to do it? You pull the power in front, and you pull it in front, so it become nx, and then the power you minus 1 become n minus 1. Alright, so as a very simple example, if let's say I'm having y equals to x squared, so how can you do the differentiation for y equals to x squared? You're having dy dx. Okay, so 2 you put in front become 2, and the x you copy, power minus 1 become 1, so it will become 2x power 1. Okay, so this is one simple example on y equals to x power 2. Okay, so how about if let's say they actually want you to get this one? If let's say they want you to find the differentiation for y equals to 1 over square root x. Okay, so how can you do the differentiation for this? Okay, so please take note that you cannot differentiate it separately, top and also bottom, because some students will tell me, oh, teacher, okay, on top of the fraction I got 1, so this one I get a 0, and then at the bottom I got square root x, then I differentiate the square root x at the bottom, so you cannot differentiate separately for any fraction like this. Okay, alright, so what is the correct way for us to do it, to do the differentiation here? So first, you need to change it, at least become x power n first. So square root x means x power half, right? Then it is at the denominator part, so when you bring it up, it will become x power negative half. So your y is equals to x power negative half. Therefore, when you do the differentiation, so again, power, put it in front, become negative half. X you just copy, and then the original power minus 1. So negative half minus 1 become negative 3 over 2. So this is your differentiation for 1 over square root x. Right? Okay, so next one. a function of the form kx power n. So if let's say you are having kx power n, then what you do is that the k, you just copy it. Don't do anything with the k, and then you are differentiating the x power n followed by k. Okay, so you are focused on the x power n. So when you differentiate x power n, and you put it in front, copy the x and then n minus 1. Alright, so maybe I can give you a very simple example on this. Alright, so maybe you can try this. Okay, let's say I'm having y equals to maybe 3 over x squared, let's say. Okay, so again, for this equation, it is a fraction. So you need to change it become 3 and then x power negative 2 first. You bring it out, become x power n pattern, then only you start differentiating it. So when you're having the dy dx, 3 is a constant, you just copy. Negative 2 is the power you put in front, become 3 multiplied with negative 2. X you copy, power minus 1 become negative 3. So if you rephrase it again, you're having negative 6 over x power 3. Alright, so this is the third rule that you should know. Then next, we go for the fourth rule. Alright, so for the fourth rule, we are talking about the sum, the derivative of a sum or a difference. Alright, so now, when you are having addition of difference or fraction, okay, for two functions, you can differentiate it separately. Alright, so as an example, if let's say I'm having let's say I'm having y equals to maybe 3x power 4 plus 1 minus x. So 3x power 4 is one function, 1 over x is another function. So you're having a function plus another function. So we're having applied to do the differentiation, you can differentiate it separately. So that means you can differentiate 3x power 4 first. You will have 12x power 3 plus, you just copy a plus. Okay, so the 1 over x, before you do the differentiation, you can rephrase it become x power negative 1. Alright, so when you differentiate x power negative 1, you have negative 1 in front, x, and then power minus 1 become negative 2. So if you rephrase it, you have 12x power 3 minus 1 over x squared. That means you differentiate term by term separately. When you're having addition, or even if a minus sign also can, plus and minus, you can differentiate separately. Okay, but if you're having a fraction, so like what I showed you just now, 1 over x squared, you cannot tell me that, oh, teacher, I want to differentiate it separately, top and bottom. So differentiate 1, I got 0. Differentiate bottom, I got 2x. This is wrong. Okay, so for any fraction, you can only do it like this for the differentiation. So please take note on this part. And then for multiplication, also the same thing. If let's say I'm having something like this, I'm having x squared, and then let's say I'm having 1 over x plus 4. Or maybe I put it in a simple equation, and let's say x squared and x power 3. So you cannot tell me that, oh, teacher, okay, to get the differentiation, I differentiate x squared, then I have x. And after that, differentiate x power 3, I got 3x squared. Differentiate plus 4, I get a 0. So my answer is that this is also wrong. Okay, for any multiplication and fraction, you cannot straight away differentiate them like this. Alright, you have to change it into the proper pattern first. Then only you can do the differentiation. Alright, so it is just a very simple revision for all the rules for differentiation. So I hope that you can recall a bit of something that you have learned before. Alright, okay, so let's go through the example 1. Okay, so maybe for all the example, for today we are going to discuss on the example 4. So if let's say you still remember with all the rules, you can pause this video again, and then you can try to complete example 1 until 4. then you should check the answer and see whether is it correct or not. Alright, so because all these examples are quite simple, but it's just a very simple revision on differentiation. Okay? Alright, so first example, I'm having this. They want you to differentiate this expression with respect to x. So to write out the symbol correctly, I want to differentiate this expression. Okay, so with respect to x. So it is a expression with plus and minus. So you can differentiate it separately. Differentiate for x, you get a 4. Alright, so differentiate 6x power 2, 6 over x power 2. So again, this one, in your mind, you should know that it is actually 6x power negative 2. Okay, so when you do this differentiation, you should have 6 and then negative 2, x power negative 3. And differentiate negative 2, you get a 0. So eventually, when you try to simplify everything, you should have 4 minus 12 over x power 3. Very simple, right? I hope that you still remember all this. Okay, then now you go to the next one. Okay, so besides all the basic differentiation on top that we discussed just now, we are having some simple rule for differentiation as well. So let's have a look for the first one, chain rule. Okay, so the chain rule is you are going to apply it when you're having function inside another function or when you're having a composite function. Okay, alright, so for any chain rule is like this. Okay, so generally you want to find out dy dx. Okay, and the chain rule is dy over something multiplied with something over dx. So you can see that you still get dy dx. So the something here actually depends on the question that we have. Right? Okay, so you have to make sure that these two something here should be the same. So as example, you're having dy over du multiplied with du over dx. So the concept is something like you cancel off the du, then you get back the dy dx eventually. Alright, okay, so this is what we call as chain rule. Okay, so we will apply chain rule very often in the application part that related to rate of change. Okay, but for rate of change, usually we are going to get dy dt. Alright, so you're having dy du, then du dt. Okay, we'll apply this formula very often, okay, in the question that involve rate of change. This one will be another video in the future. Alright. Okay, so this is what you have for the chain rule. Okay, so let's have a look and see how we apply the chain rule here. Okay, so as an example, we look for example 2. So for chain rule, usually we will apply it when you're having a bracket with a power outside and you want to find out the differentiation. Okay, so as an example, okay, so you see that this is a bracket. So usually I will let maybe u equals to the expression inside the bracket. So I let u equals to 3x squared minus 2. Okay, so I can find out the differentiation for du over dx first. Alright, find out the differentiation u with respect to x. So you're having du dx. Differentiate 3x squared, you're having 6x. Differentiate 2, you have a 0. So du dx equals to 6x. Alright, so once you substitute this whole thing as a u already, therefore your y will become u power 5. So to differentiate this, y equals to u power 5, you're having dy over du. So what is dy over du here? You are having 5u power 4. Okay, so eventually what they want you to find is dy dx. So how to get the dy dx? You should combine it by using dy over du multiplied with du over dx. So what is dy over du? This one, 5u power 4. And then what is du dx? This one, 6x. So 6 times 5, you get 30. And then you're having x. And then u power 4. And again, because my original question, there's no u1, right? Okay, so I should change the u. Go back to 3x squared minus 2. Therefore, I'm having 30x and then 3x squared minus 2 power 4. Alright, so this is my final answer for the differentiation of this part. Okay, so I believe that you look at my solution here, you'll tell me, oh, teacher, actually no need to be so long, right? Because actually we learn a shortcut to get the differentiation for this kind of question. Yeah, I understand. All right, but for now, I just want to introduce how we use the chain rule in this kind of question. So that's why I show it in a long way. Okay, all right. Okay, so now just to try for your understanding, if you want, you can try part B. Pause this video and try part B first by using the chain rule and see whether you can get an answer or not. All right, again, I understand that this is not the best way to get the differentiation for this, but we are just trying to revise it with the concept of chain rule. Okay, so now for part B, how can I get an answer for part B? Alright, so for part B, it is y equals to, I can write it become 7x minus 2 power half. Okay, so first you can let u equals to 7x minus 2, then du dx equals to 7. Alright, then after that, you can let, you are having y equals to u power half, and therefore you have dy over du, which is equals to half u power negative half. Alright, so to get the dy dx, you should have dy du multiply with du over dx. Okay, so what is dy du? Dy du is 1 over 2 square root u multiply with du dx, which is a 7. Okay, so to rephrase it into in terms of x and y, I'm having 7 over 2. The best way to get an answer, but to revise the concept of chain rule,